have a long history with Dune. My dad took me to see the Lynch adaptation in the theater. I was 7. I don't remember it being particularly traumatic, but you can judge for yourself how I turned out. And he wasn't wrong about me loving it just about 10 years too soon. So, yeah, I've read them all multiple times and seen every theatrical version made. I even tracked down the fan edit of Lynch, which really does an amazing job of incorporating every little bit of deleted material. And there is one aspect that has always particularly fascinated me: the thumper. This is the device used by the Fremen to create rhythmic vibrations and attract the sandworm. They're not very well described in the book, but it is evocative.
Stilgar pulled a plastic rod about a meter long from beneath his robe. The thing was pointed at one end, had a spring-wound clapper at the other end. I prepared this thumper myself. It's a good one. Take it.
The way that they are triggered is likewise vague. They have a time delay mode.
I planted the thumper in the deepest part of the crevasse, Paul said. Whenever I light its candle, it'll give us about 30 minutes.
But also a way to directly set it off.
Stooping, Paul planted the thumper deep into the windward face where the sand was compacted and would give maximum transmission to the drumming. Then he hesitated, reviewing the lessons, reviewing the life and death necessities that faced him. When he threw the latch, the thumper would begin its summons. Across the sand, a giant worm, a maker, would hear and come to the drumming.
They've been portrayed in movies in a variety of ways, none of them particularly faithful to the descriptions we have. I'll always have a deep fondness for the Lynch version, but the large ones seen there look really impractical. Paul talks about taking a 20-thumper journey to the south. Even with resupply along the way, how many of those could you actually carry? The one from the sci-fi miniseries is okay, and Villeneuve at least captures a bit of the clockwork feel, but still seems needlessly complicated. Fundamentally, I was never going to be satisfied with one, unless I built it myself. What I wanted to make wasn't a movie prop replica. It wasn't even a direct implementation of the brief description Herbert gave us. I wanted as real of a thumper as I could make, one that felt true to its setting. It needed to be reliable and ruthlessly practical. It also needed to be fairly easily manufactured. We know the Fremen have advanced fabrication capabilities, but this is still a disposable item made by a severely resource-constrained people. It needed to be highly portable, quickly deployed, and easily triggered with a time delay. It needed to be something I could actually imagine the Fremen using. So here's how I went about that. First off, the selection of a power source. Now Herbert says clockwork, but that sounded very fiddly and delicate to me for something that has to live in the bottom of someone's bag while crossing a desert. I rejected electricity straight out just because it's kind of boring, and who wants to deal with keeping a battery charged anyway? I decided compressed air was the way to go. It has the proper low-tech / steampunk vibe while still being very practical. It can be stored easily in the form of a CO2 cartridge, the kind used in air guns. Safe and cheap, these seemed like an ideal Fremen power source. With that decided, it was time to start experimenting. I was thinking it could work like an air hammer, as in a pneumatic jackhammer. After looking at some old patents, I came up with a simple design that seemed like it might work. The idea is that the piston is its own valve. Air is led into this chamber, pushing it away. As it moves, it blocks this port, so air can no longer get behind it. At the same time, this port is opened, letting air now blow in ahead of it. It slows, stops, and reverses course, and the whole cycle starts again. Easy in theory, and it was a fun little build, particularly drilling the ports lengthwise down the cylinder walls. I used tape to seal them up, which worked great and meant I didn't have to weld them shut permanently. And the thing worked. Kind of. The piston was definitely reciprocating, but it wasn't creating distinct impacts. I'd created a pneumatic vibrator. I tried adding these adjustable stops at either end, for the piston to slam into before reversing. It was very hard to find an adjustment that didn't just stall out the piston, though. I think this is why all the modern designs I could find separated the hammering piston from the valve mechanism. That way, if the piston gets stalled, the valve action continues, and the piston will immediately restart once it is free to move again. Not wanting to completely redesign it, I tried to separate the piston from the hammering action by adding a floating anvil. This was attached to a long rod that protruded out of the cylinder, giving a real business end to work with. This actually started to work reasonably well. There were some problems getting it going to start with, but those seemed surmountable. I made a little pneumatic testing center, allowing me to step down the 120 psi of my central air system to whatever I wanted, along with a valve for easy control. The interesting result using this was that the frequency of the air hammer didn't seem particularly well correlated with the pressure I was running it at. At lower pressures, it just wouldn't run at all, and once it was running, upping the pressure didn't make it go much faster. This raised an important design question. What frequency should I be aiming for? All the theatrical versions show thumpers running pretty slowly, maybe 1 to 2 hertz? The books don't specify, but they don't make it sound particularly fast either.
Time stretched out around them. The rock face ahead seemed to grow no nearer. The one behind still towered high. Lump, 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 lump. It was a drumming from the cliff behind. "The thumper," Paul hissed. Its pounding continued, and they found difficulty avoiding the rhythm of it in their stride. Lump, 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 lump.
But we also know that sandworms are attracted to all mechanical activity, even the centrifugal separation of spice from sand. Any vibrations from that have got to be much higher frequency. Same with any kind of combustion engine powering ground transport. If you could avoid sandworm detection just by revving the engine faster, surely they would have done that. I had to assume that a higher frequency thumper would be perfectly acceptable. Unfortunately, that wasn't the main problem with the air hammer design. Thinking I might be getting close to a working system, I tried hooking up a CO2 cartridge as the power source. It bled out in seconds, only getting a couple cycles of piston movement before dying entirely. That definitely wasn't going to work. Depressed, I returned to the drawing board and tried to think through the problem. What I wanted was a way to let pressure slowly build up in an accumulator, then be released all at once, blasting the piston up the cylinder. The accumulator closes, the piston slams back down to the bottom of the cylinder, and the cycle repeats. Thing is, I'm not exactly an expert when it comes to pneumatics, as cool as I think they are. I tried getting a pressure relief valve, thinking it might release the pressure fast enough to create the kind of cycling I wanted. Instead, it just continuously bled off pressure at its release rating. Friends, I had reinvented the regulator. Getting fancier, I looked into the triggering mechanisms of potato cannons. These often use a quick exhaust valve, or QEV. These are made for hooking up to a pneumatic cylinder so that once input pressure is released, all the air in the cylinder can be quickly dumped out locally, instead of having to be routed back through all the valving, which might be some distance away. This lets the cylinder retract much faster. The application of this to ballistics is fairly obvious. It seemed promising, but I quickly realized I needed something that worked backwards from this. Getting desperate, I Frankensteined a monster using a QEV, the pressure relief valve, and a pressure-activated switch. The idea being, pressure builds up in the accumulator until the relief valve starts to release it. This causes the pressure-activated switch to open, releasing the input pressure, which is also holding the QEV closed. It opens, dumping everything in the accumulator out into the cylinder. This was getting excessive, and definitely was farther and farther away from the simple, robust system I originally had in mind. It also did not work at all. I was now 2 months into what I had thought would be a 1-month project, and I had achieved absolutely nothing except despair. But I just couldn't stop thinking about the problem. I had some vague ideas about using the cylinder for the accumulator, and some kind of detente system to hold the piston in place until the pressure got large enough. I tried to prototype this using a handheld hex key as the detente, just to see if it could work at all like I was thinking. And then something fabulous happened. It worked even without the silly detente idea. The piston was oscillating in a completely unvalved, uninstrumented, unmodified cylinder, and it wasn't using much air to do it. Some quick and dirty iterations convinced me. I had a solution here. By adding a crossbar, the piston had something solid to impact against before it was cushioned by the accumulating pressure. The cutouts allowed the pressure to escape from below it, also providing a very welcome aesthetic improvement of allowing the piston to be seen in motion. Running it on a CO2 cartridge would give 2 to 3 minutes of runtime, which is a bit less than I hoped for, but acceptable. We know worms will come with much less provocation than that, after all. I finally had a working mechanical design. The next problem to be solved: how does the thumper get activated? Herbert describes a latch being thrown or a candle being lit. Now, a latch could be a valve opening, but a candle? How does a candle release pressure? On a whim, I searched for a pyrotechnic relief valve, mostly to amuse myself. And yet, sometimes the universe provides. This is a fusible plug. It's a little pipe plug with a hole drilled through it and filled with a specific low temperature alloy. If the temperature gets that high, it melts, releasing the pressure inside. You can get them calibrated to blow at a variety of different temps. The pamphlet that came with my order introduced me to a whole universe of fusible links, letting all kinds of mechanical actions happen when the temperature gets high enough. Good to know. I started testing fusible plugs. First, just setting one off with a torch. Woo! That was a lot more violent than I expected, with only about 20 psi of pressure behind it. That could be a problem if it sprayed the molten metal onto the piston in the cylinder, soldering it into place. Next, I tried it more like I was imagining it would work in the thumper. Set up vertically, with a fire on the outside heating things up. This is some Kevlar wick I've had sitting around since the harmonic fire pendula project 10 years ago. The fuel was just denatured alcohol, since I keep a spray bottle of that in the shop, but it seems reasonable that some flammable liquid would be part of the standard Fremen kit. This time, the results seemed very promising. So that's how you trigger one more or less immediately. How do you achieve a time delay response, like the 30 minutes we first see Paul talking about? Well, what about using a fuse? This also seems like something a Fremen might have on hand. This rocketry fuse I found burns at about 50 centimeters a minute, and lit the wick just fine. Boom. That was the last big question mark that I knew about. Time to start building a thumper for real. I started with a commercial CO2 cartridge adapter. This saved me the effort of figuring out the puncturing mechanism, and seemed within the frugal nature of a Fremen workshop. Of course they'd use commercial off-the-shelf parts if available. I was happy to use the adapter, but the sleeve it came with wasn't acceptable. This holds the CO2 cartridge and pushes it up into the adapter. Screw it in far enough and the cartridge nozzle is pierced by the adapter, releasing the pressure inside. My version had a nice chunky gription section, cut on the mill with ball-end cutters. I made the sleeve longer than needed, and beveled the end of it so it could be jammed into sand as part of deployment. Of course, I didn't bring it quite to a sharp tip. This might be rattling around in your bag for months on end. Sharp edges in a Frem kit have to be rarer than on an EVA. Imagine the embarrassment of poking a hole in your still suit. The other side of the cartridge adapter screwed into what I called the restrictor. This had a very thin hole for the CO2 to flow through, feeding into the fusible plug. This would allow the cartridge to be screwed in, arming the device. But until the plug was melted, nothing would happen. Also screwing into the top of the restrictor was the cylinder. This has a steel cross rod for the piston to impact against, but otherwise it's made of aluminum like everything else. Light and easy to machine. Very Fremen. I made a custom form cutter to cut these grooves into the restrictor and the cylinder. These mark where the wick needs to go and provide some grip to make sure it doesn't slide down. With the wick in place, just add some fuel and set it alight. After about a minute of burning, the plug will get to temp and... Well? Okay, that was kind of awesome, but a lot more violent than I was expecting. Those CO2 cartridges really spike in pressure when they're first released. I learned two things from this. other than that I had been right to be paranoid and wear a full face shield for the test. 1. The cylinder needs some kind of cap to make sure the piston doesn't fly out like that. I had already been thinking of adding one so the wick could be stuffed down there during transportation, so that was easy enough. Note the hole to let air out. Without that, the piston wouldn't slide properly due to the air cushion. 2. The restrictor wasn't restricting nearly enough. My intuitions about air flowing through narrow holes was obviously quite flawed. If I wanted a needle valve in there, I was going to have to add one. This marked the beginning of the second valley of frustration for this project. I ended up making 4 different restrictors, trying to make a quick and dirty needle valve with various screws. None of them worked at all. I finally decided the Fremen thing to do was, again, use a commercial part. I had needle valves that I knew worked just fine, since that's what I had been testing with originally. But there were a couple issues with using them. First, they had to be very finely adjusted. That would have to be done once at the factory, as you can't exactly stand around tweaking things once a thumper has gone off. They would also have to be protected from the triggering fire to some degree, as they have internal seals that could melt. And finally, they just look too modern. The first problem I solved by removing the valve handle entirely and cutting the stem down to barely project above the gland nut. I cut a slot in it so it could be adjusted by screwdriver, but otherwise it wouldn't easily move. The second 2 I solved with the addition of a shroud to cover the valve entirely. Now it can't be seen and is shielded from the fire, even if the burning fuel drips down. I even added a little recess for the extra fuel to burn in, for maximal frugality. It was time for a full systems test. Ignition via fuse, CO2 cartridge, everything. One small hitch, the plug didn't melt before the fuel ran out this time. More wick would be needed. But once that was sorted, it all worked. And I was able to get some fun slow-mo of it starting up. It remains a fairly violent process, even with the needle valve. I remade the cap and the cylinder. The cylinder was getting pretty beat up from testing, and I wanted it longer so it could carry more wick inside. And the knurling on the cap just didn't look right to me, so I replaced that with grooves to match the grip section on the cartridge sleeve. And that finished the project, other than making this video. It had taken many months longer than intended and involved far more iterations than I would have desired, but it was done. I had a thumper. A real thumper, not a prop. Very possibly the most real thumper ever made. Now all that was left was to test it.
From the Siege Tabor Mark IV Thumper Field Guide by the Princess Irulan. To deploy your thumper, first remove the cylinder cap, being careful not to lose it. Next, extract the spice fiber wick from within. Replace the cap and invert the thumper to confirm free motion of the piston. If it does not slide freely, clean the cylinder now. Note: do not remove the shroud or alter the valve unless you are a qualified FremKit technician. The valve has already been calibrated before field deployment. Affix the wick around the outside of the thumper, between the shroud and cylinder slot, in the area indicated by the grooves. Try to keep the wraps within this area to concentrate the heat where it will be needed for deployment. Using less than the provided amount of wick is not recommended. Remove the lower sleeve and remove the compressed air cartridge inside. Invert the cartridge, replace it in the sleeve, and screw the sleeve back on tightly. You might briefly hear a faint hissing sound as the cartridge's seal is pierced. The thumper is now armed. Moving without rhythm, find a section of properly compressed sand. Always have an escape route in mind. Insert the thumper at least up to the grip section of the lower sleeve. Tipping over during operation is one of the most common failure modes during thumper deployment. For a time delay deployment, attach the appropriate length of fuse. Please see Siege Tabor Munitions Guide for details. apply fuel to the wick on the thumper. Light the wick, or for time-delayed deployment, light the fuse. Note that alcohol flames are very difficult to see in direct sunlight. Look for the heat distortions around the shadow if there is any doubt as to complete ignition. The thumper will begin operation within 1 minute of ignition. It is highly recommended that you leave the vicinity of the thumper after operation has begun. Bless the Maker and his water. Bless the coming and going of him. May his passage cleanse the world. May he keep the world for his people.